Hello, today we're looking at multiplying fractions. Now, after doing addition and subtracting fractions, multiplying fractions is actually much easier. Let's start off straight away with an example. I'm going to take 3/8 multiplied by 2/5. Now, when you are multiplying fractions, all you do is you take your numerator and you multiply them together. You take your denominators and you multiply them together. It is that simple. So in this first example, we've got 3 times 2 is 6 over 8 times 5 is 40. Now, that is a correct answer, but not a complete answer. Immediately, you should spot that both 6 and 20 are even numbers. So I can divide both the denominator and numerator by 2 to leave me with 3 over 20. And there's your complete answer. I'll do another example. Let's have 3/4 multiplied by 2/7. Again, I take numerators, multiply them together. I take the denominators and multiply those together. 3 times 2 is 6. 4 times 7 is 28. Again, spotted straight away. They're both even numbers. I can divide by 2. Gives me 3 over 14. Have a go at these two yourself. We'll have 6 over 10 multiplied by 3, oops, got a funny squiggle on the page, 3/4, and number 4, 5/7 multiplied by 2/3. Pause the video, work your way through, and then check back to see if you've got the same answer. As before, 6 times 3 is 18 over 10 times 4 is 40. Immediately, I've spotted they can both be divided by 2, will give me 9 over 20. Same principle again. 5 times 2 is 10. 7 times 3 is 21. However, this time you can't cancel. Okay, so this is how you multiply fractions for simple fractions with a simple numerator and denominator. There is a second method where you cancel before you multiply. This is useful when you've got very large numbers. I'll show you an example. If we take 15 multiplied by 15 over 21 multiplied by 18 over 25. Now, what we can do is we can simplify the fractions, but we don't just have to simplify that and simplify that. We can cross simplify. Now, this is useful when we've got large numbers like this. Yes, I could do a long multiplication and work that all out, but actually if I simplify first, the numbers become easier. So anything which is the numerators can be simplified when you are multiplying against anything on the denominators. Now, the first thing I'm going to do is I've spotted a 5 because 15 and 25 are both in the 5 times table. So immediately I can think, right, let's get rid of this. How many 5s in 15? There are 3. How many 5s in 25? There are 5. Excellent. Again, I'm looking for connections now. Actually, I know that both 18 and 21 are both in the 3 times table. There are 7 3s in 21 and there are 6 3s in 18. Now, I know that both 3 and 6 are both in the 3 times table again, but they're both numerators, so I can't cancel that down. Once I've double checked, that's as far as I can go. So I'll have 3 times 6 is 18, all over 7 times 5 is 35. I'll do another example. 20 over 35 multiplied by 45 all over 60. Again, I can take any of the numerators and any of the denominators and simplify. So this time 45 and 35 both end in a 5. Oops, my pen's not working, bear with me. No, use another one, Mrs. Patmore. That one does. Both in the 5s. How many 5s in 35? There are 7. How many 5s in 45? There are 9. Let's have a look. Oh, 20 and 60. I can divide by 10. So that gives me 2. That gives me 6. Right. Oh, 2 and 6. They are both in the 2 times table. So I can take 2, takes me down to 1. 6 takes me down to 3. Right. So I've got 1/7 over 9 3s. Now, as you can see here, we've ended up with a vulgar fraction. Because we've been simplifying across the multiplication, this doesn't matter. The same principle still applies. Right, just trying to find another coloured pen. Let's try this one, see if this one works. No? Right, I'll have to just go back to using blue again. Now, 9 and 3 are both in the 3 times table. So that 9 will become 3 itself, and that 3 will become 1. So I'll end up with 1 times 3 is 3, all over 7 times 1 is just 7, 3/7. That cross multiplication, not cross multiplication, wrong phrase, that cancelling across the multiplication makes the calculation much simpler. This is how questions like this can appear on a calculator paper. I've just realised I can't count. 1, 2, 3, 4, 4. I'll call that 4A. Get away with it. Have a go at this one yourself. We'll have 35 over 50 multiplied by 30 over 49. Pause the video and then check back in to see what answer you've got using this cross cancellation method. Same principle as before, looking at it. Now both 50 and 30 end in 10, so this can go down to 5, this can go down to 3. 35 and 5 are both in the 5 times table. So this can go down to 1, this can go down to 7. That was the 5s. 7 and 49 are both in the 7 times table. So that can go down to 1, 1 over 1, very easy to multiply by, and that goes down to 7. So we'll end up with 1 times 3 is 3, 1 times 7 is just 7. Now, if you don't understand this cross-cancelling method, you prefer to multiply, then cancel, you may. But this is a skill worth learning, because eventually when you're doing far more complex multiplications, this will help you do them far, far quicker.